Okay, this is Unit 2, Day 1, Part 2, because I have to finish it up. Part D. Between what two consecutive integers does the largest solution to f of x equal 3 lie? So if you remember, I just drew the horizontal line. This is y equals 3. And the largest value, so there's 3 numbers here. We have this first one, the second, and the third. And between what two values? So if you go down here on the x scale, it's between 7 and 8. So that's my answer here. So between 7 and 8. Example 7. For a function y equals g of x, it is known that g of negative 2 equals 7. Which of the following points must lie on that graph? Remember, this is your input, your x. This is your output, your y. So the point negative 2, 7 definitely lies on that function, of that graph of that function. So it's choice 2. Number 8. Physics students drop a ball from the top of a 50-foot building and model its height as a function of time, where the equation h of t equals 50 minus 16t squared. Using tables on your calculator, determine to the nearest tenth of a second when the ball hits the ground. Provide tabular outputs to support your answer. Well, I actually didn't use a table, and it's really hard because my screen won't let me switch, but basically I graphed this h of t. So put that in your f of x, and then go ahead and graph it, and it does absolutely produce an upside down parabola because your a on your t squared there is negative. So basically you're going to get a graph, and this is up at 50, and the parabola does something like this. It's really skinny and long. Now remember, if you're up at the top of the building, you're way up here, and just imagine them dropping the ball. So they want to know, boom, right down here, they want to know where that hits. So what I did was I obviously put in f of x, f1 of x is the quadratic that they gave me. And then this is the line y equals 0, which is actually the x-axis. So graph that in f2. So in your f2 of x, you can graph 0. That produces the red line. And then I did a menu 813, which will give you the intersection points. And you have to click on each graph. So then I clicked on the 50 minus 16t squared, and then y equals 0, and then you hit enter, and boom, this point, it appears. And that appears at 1.77 comma 0. That's that intersection point right there. So remember, this is my x value. So now it says nearest tenth, so x is going to be approximately 1.8. Okay, so that's when it's going to hit the ground.